Okay, we're good. All right. So you were saying you found the project in December, basically.
Yeah. And I've been following it a little bit on and off. And since I know Sammy, I speak to her quite a lot. So she's been really like, you should really look into it a little bit more, maybe get involved. But my time so far has been a little bit restricted. But I want to be more a part of this and actually do something with this project.
So you just said you're interested in decentralization, but it's being done wrong now.
Yeah.
Can you explain a little bit? I agree, but how is it being
basically
done wrong?
Like the many projects that I see that call for decentralization is not really being decentralized. Majority of, let's say, the computing power or nodes in whatever project it is majority owned by the actual creators or the developers of it. And it doesn't give the necessary means to the end user to maybe set up their own node server or whatever to take it back to control themselves. Which is why I see like Holochain, you can, as I understand it, you can get a box if you are not technically savvy, put it in your home and run it, which would be great for my parents and my brother and sister, for example. But for myself, well, I have rack servers that I can utilize for this, for an example.
Sure. It's actually even more than that. You don't need to get a box.
Yeah.
For Holochain, you can just use your cell phone. With Holo, you don't need to get a box either. You could just use your laptop or something. You're probably not going to do the web hosting on a cell phone if you're running Holo.
No.
Holo's basically hosting, right? But yeah. So why is that a problem? Why is decentralization a good thing at all? Like, what does that matter?
It's self-governance. Like as more user comes into this, makes it more strong, and we can set up nodes that goes faster directly to peer-to-peer instead of actually going around to the network. They can actually be either tapped by a company that wants to get some side information, geographics, or use your gender or whatever type of information. So decentralization becomes the trust lays on the end user instead of trusting one company with all your information and connections to all the other people. So in some projects that are decentralized, we're talking about mainly Demon Saw.
Yeah.
For example, one great project. It's still run on majority one person that are hosting a bunch of routers. That person controls those routers. People do not take their own means to set up their own router to actually make it more than process, so people can jump somewhat in a centralized way using that product.
Yeah.
So
yeah,
it's a little bit. It's a whole new era of this decentralization, and many people do not actually realize how a lot of things are being built up. And I think it needs a lot of information going out to the actual end users to be aware of where the information is going and where it's stored and so on.
Yeah. And your background is security, yeah?
Yeah, a physical security for home and public buildings.
Okay.
So like locks, doors, entrances, surveillance systems, and so on.
And I guess if somebody hacks that, that's not good.
No. So a lot of the times it's off the internet, majority security. Okay. But the clients demand an IoT thing because they want to use an app, which I really discouraging people to use. They should not be using that at all, in my opinion. They want security, but they also want the convenience, and then I just say, well, do not, just skip that part. You just skip the internet connected devices at all. Your own.
What's your preference there? Is it like smart card type, RFID or near field communication cards?
Yeah, actual old-fashioned PIN codes. It's a lot better because a PIN code you can remember and it change every 3 months. That is perfectly fine, and most people actually remember a simple 6-digit PIN code that gets updated every 3 months. Mm-hmm. That's good enough security in most cases. Mm. It just depends about what you actually are worrying about. If it's just like thieves and things like that, that is going to be fine.
Yeah. Cool.
And then we have some customers that are for the government, school buildings and things like that, but then it needs to be easy, so that RFIDs is the actual choice for them. Yeah. Because it needs to be so they get new cards every 6 months, I think it is. Mm. So it makes it easier.
And that enables them to revoke permissions on a individual basis, etc., or allocate different permissions, etc.
Yeah, and also, since they're swapping out the cards every 6 months, it makes it so if a card would be cloned somewhere, that will be obsolete and not be able to be used after 6 months.
Yeah, it limits your exposure time. Yeah,
exactly.
Yeah. Cool. And how did you get into all of that? What trauma did you experience? This is becoming my new favorite question. What trauma did you experience in your childhood, that led you to...
The thing is, I've been grown up, I think I've been a tinfoil hat type of person my whole life. And I saw security flaws in everything as a kid and growing up. So I thought it would be really important to educate people in this and make their life safer and easier.
Yeah.
Because security should not be hard and everybody should have security. So my worst thing is when I was a kid, a lot of people left the doors unlocked. It was a kind of, I grew up in a smaller city, and when we went over to somebody's house, the door often was unlocked, and even nobody was home, you can just walk in and wait. Which is really, for me, really it doesn't feel very well knowing that my home is unlocked. Even though everything is safe and my neighbors are good, I just don't like the feeling of it.
Yeah. I remember a friend years ago pointing out to me that the best security minds in the world are just so paranoid that they have it's actually the best guys. It's really hard to do any work with them because they're so paranoid that the very thing that makes them so good at that line of work makes it so hard for them to work with anyone else. It was pretty funny. In terms of cryptographers, etc. He's
don't want to share anything.
yeah. He's one of the folks who works on capabilities-based security. He's part of that community. Pretty funny. I'm actually trying to remember. There's a book that came out that he actually gave me called, I think it was called Usable Security. And it was a bunch of short articles. One in particular by Ka-Ping Yi. Do you know Ka-Ping Yi?
No. Doesn't ring a bell.
Aligning security and usability. Let me see if I can just drop the link in here. It's great. This book in particular was just wonderful in general, but it was Ka-Ping Yi, who I got to meet not too long ago. He was much younger than I thought he would be. Did a really, so much of it was about the whole key to designing systems that are both usable and secure is making it so that the easiest thing for the user to do is the most secure thing.
Yeah.
Right.
Only creating one path for it.
Yeah. Exactly. And making it so that in order to do something that would be less secure, it would actually be far more inconvenient for them. And
exactly.
yeah, it is a wonderful sort of set of principles, design patterns or principles.
That sounds really interesting to get a read on that.
I just dropped a link into the chat that I think is the article.
Oh, great.
Cool. So, is there anything I can? So my job basically at the moment is running around Europe, building community around Holochain, and my title is the Director of Communications. And though I might be shifting towards something more like how that sounds in the near future, at the moment I'm basically spokesman. You know, I'm pretty much running around and telling the story and walking people through the details when they want to walk through the details. Now that said, I am not a developer. I put my hands on keyboards occasionally, not much. I'm a decent architect, and I've been part of this project for 4 years. But my role is largely explaining what this stuff is. But if there's anything in particular, you're like, all right, well, what about this? Or how about that? Or is anybody doing blank? Is anybody building, an app that does this? Or how are you guys solving gossip or whatever? I would love to be able to answer anything you got.
My biggest question is like, how is this addressing malicious nodes, and how the whole ecosystem is having an immune system that automatically recognizes this? Is there anything like that in this ecosystem of?
Yes, there is. And it's at 2 layers. So at the automatic layer, I'll do just a little background, and I won't go into too much detail because I'm going to assume that you know some of this stuff, or that if you're like, hey, can you go into more depth there? Just say go into more depth there.
Absolutely.
So there's not one big Holochain, right? Each application has its own separate namespace, members, rules, etc. But if you and I are running an application, we're running it with one identical code. The application code is identical on my device and your device, so we're playing by the same rules. If this is peer-to-peer Twitter, maximum 140 characters in a tweet, right? Cool. So identical rules. 2, when you initiate an application, the first time you fire it up, you create automatically a public and private key pair, and you may have some other steps that you jump through for other identity conditions that application would require. A relationship with some other app, or that's up to the developer. But the default is, hey, you've got this set of keys that will be your identity, your initial starting identity in that application space. It's not related to anything else in the world, but there. And just like any other set of public-private keys, it's useful for a few things. 1, people can encrypt content and send it to you in a way that only you can read. 2, you can sign things that others can check because there's a mechanism for making your public key visible to the world. And 3, the hash of your public key serves as the address, your device's address in the distributed hash table, which is our shared storage space. The third part, so we've got shared code, keys, or identity basically. The third part is each party has their own local source chain, meaning their own local hash chain of the activities that they participate in. So each time you do something in this space, you sign it with your local key and you add it to the log. Then when you do another activity, you sign that and you include the hash of the previous activity in with that and add it to the log, and so on and so forth, right? So that makes it a tamper-resistant log. Now, it's not really tamper-resistant until you share it with somebody.
Yeah, I was going to say, well, it's only 2 parties. You need somebody to verify.
Exactly. Once you're sharing it with others, they're seeing that you had hashed something, and if you try to change something in the future, this hash will make visible that, hey, something shifted here. But once you share it, it makes that visible. So you've got your own little local store, and what that means is you actually have your own storage of your content as well. So you're always holding on to your own data, but you're doing it in this structure that is a tamper-resistant log. The fourth part is a distributed hash table. So after you check your own rules to see, is this playing by the rules? Yes, it is. You sign it into your own log. You then share it to the public space, basically this space, the shared space for this app. What is a distributed hash table for? Well, historically, it's been used for peer-to-peer file storage. And the problem that it solved was, how can we put a piece of content? We've got a network of computers. How do we decide where to put that so that even though people are jumping onto and off of the network, later when somebody comes to ask for that content, they know where to look, right? And so the solution is basically, hey, we will put the content we will choose the location based on the content itself. We will take the content, we'll run it through a hash function. That gives us a little fingerprint, a digital fingerprint. Each of the participants, each of the machines in the network also have an address that is the hash, the digital fingerprint of the public key of that user. And we'll compare these. We're looking for who's closest, right? These are each 100-digit numbers, and they call it XOR logic. So you're doing a comparison. And we're looking for, how close are you to this? Okay, do you know anybody who's closer? Who are the top 3 that you know that are closest to this? And they hand that back. So I reach out to the top 3 that I know of that are closest to this thing, and I ask each of them to send me their top 3, and it could include them. They send that back, and then I read, and so it's a bunch of these back and forth hops, right?
Exactly, and you end up with the actual
bingo.
file list.
I find the closest party of the network or the closest 20. And in a Holochain app, this is a thing that the developer can decide how much resilience do we want? How many copies do we want to make? Now, let's say it's peer-to-peer Twitter, and we want 20 copies. Great. So I then find the 20 nodes that are closest to this address. But the only thing that's been getting passed around the network at this point is this little hash, right? This tiny file. Once I find, let's say, your device, and you're like, yep, I'm supposed to hold on to that thing. I don't know anybody closer. You then say, send me the file. Send me the raw data. And I send you the content as well as any other material that you're going to need in order to run the validation.
Okay. Yeah.
Right? So if this is the one transaction, and this is some like currency type system, I'm also going to send you the history of transaction, right? And whatever else is needed. So I package that up, I send you the validation package, and you then check your own set of the rules. You check the signatures on all these things. You reach out for the information that you need in order to validate this.
Yeah, exactly. You do it on your local end. So
Exactly. You're checking your own copy of the rules, and if from your perspective, this thing plays by the rules, you then make a statement of, yes, this looks valid to me. And you sign that, and you append that as metadata on your copy of this piece of content. So there's 2 things that we did differently with our distributed hash table. One, we made it validating in this way. So we have nodes who validate in a distributed way. And 2, we add metadata. So you can append, yep, I'm stating that it's valid. Or you can append things like, the link for the update is over here, right? Like, this is deprecated. I no longer stand by this. You'll find the update over here. Because since content in a distributed hash table, since its location is based on the content itself, if you change the content, it's suddenly living somewhere else.
Exactly.
The way that you manage updates is by this sort of pointer to the new piece of information.
Yeah.
You can also, if we were doing peer-to-peer Twitter, the way that this works is when you actually tweet, your machine does 2 things. One, it does this type of process that we just talked about for putting the tweet out there so that others can find it. And 2, it sends the link for that tweet to maybe your user profile, right? So you've got metadata hanging off your user profile, and you have tweets there, and it says, hey, Marvin did a new tweet, it's over here. And when somebody who's following you jumps back onto the network, if this is like a poll architecture rather than a push architecture, they would just check, hey, what has Marvin said lately? They read down the list, hey, that's new. Cool, let's go grab that content. Yeah. So you had asked about immune system. Well, so let's look at what happens if you have a malicious node.
Yeah, exactly. So if somebody goes in and edits something.
Yep. Well, one, if they edit the thing, you're checking signatures, right? And so the piece of content
exactly.
wouldn't match the signature. It would break the signature.
Exactly.
So that makes visible right off the bat. But let's say you collude with the author, right? So there's you and I get together and I pass something that's 200 characters instead of 140 characters. That's a poor example of why somebody would want to cheat, but whatever. You say, yep, it looks valid, right? And you start passing that around. Well, the parties that are around you in the network, they are also checking content, meaning around you, not geographically, but in this hash address space. Okay?
In space, yeah.
And when there's in a Holochain application, where this content is going to live is based on the proximity to the hash of the user of their public key. And so that piece of content hashes to some number, and it basically is going to get randomly spread across the network.
Yeah.
Okay. Now, you could have waited until you found a piece of content that hashed close to your colluder's address, but there's going to be a bunch of other folks in the network who are also close to that. And so you would have to control more than, let's say, 95% of the nodes in the network, or more than 90% of the nodes in the network, in order to try to commit this type of fraud without being detected. Because the parties around you, as soon as you start trying to pass bad data, somebody around you is going to see that, go, wait a minute, when I checked that content, it didn't comply, it wasn't valid. This guy's passing it, saying it is valid, and they then raise a flag. They can raise a flag to all the other parties in the neighborhood, is what it's called. Yeah. All the parties near them, and go, hey, Marvin is passing bad data, and here's the evidence. Here's his signature on a piece of content. Yeah. You can check that piece of content, recognize it violates the rules, see that he did sign this thing that's violating the rules, but he said it was good. He's been hacked, or he's got a bug, or something's going wrong here. No good, right?
So it propagates out to all the neighbors around it.
And each of those neighbors makes their own independent determination of whether they're going to continue chatting with Marvin, right?
Okay.
They check and go, oh yeah, he's fucking passing bad, pardon me, but he's passing bad data.
Yeah, no problem.
No, I don't want to listen to him anymore. No, I don't want to send data to him anymore. Now, there's probably some set of settings in that application for how to react when you experience that kind of bad data. The first time, maybe it's just we'll ignore that. But if you build up some history there, you might start to just ignore everything together and stop sending data to that person. You just pretend that they are no longer running this app, despite the fact that they
pushing them out a little bit.
Exactly. Yeah. And so you would dial what those settings are for the immune response, right? What the action is that gets taken in an application-to-application basis. But the automatic layer is hey, wait a minute, we just realized that there's a problem here, and sending warning signals around about that. So that's the basic gist.
Yeah, that's very cool that it actually has two functions with it. And instead of just like, oh, this is bad, you just toss it on the side, it actually validates a little bit more than just that.
Yeah, and it could be that the members of your community decide that even though it wasn't written in the rules, this is how we want to play. Like, even though they didn't upgrade the rules, they might go, well, that's a close enough thing. And so you can get some migrations in terms of the culture without having it actually embodied in the code, which is how the world actually works. Now, I don't know how much that's going to really happen, but it's something that you could see emerge.
That could be something that involves more by community basis.
Exactly. Yeah. So there's a couple of things that become interesting here with this architecture. One, if we're doing peer-to-peer Twitter, how much content am I holding on to? What's the burden for running this kind of application? Well, I've got to hold on to my tweets, and I've got to hold on to about 20 times the average user's tweets, right? Yeah. And so if I'm tweeting about as much as an average user, I've got to hold like 21 times as much as my own tweets, essentially.
Yeah.
And when people reach out for content, I'm going, yep, I've got that, and I'm sending them that. When people create new content that happens to land with me, I'm going, yep, here you go. Let me validate it. Okay, it looks valid, and then I'm making it available to others. Occasionally, I'm chatting with the devices near me, going, hey, have you seen this? Right? Or them reaching out to me, hey, we've got this new thing. Have you seen it yet? Oh, no, cool. And then I would reach out to the user themselves to get the validation package and do my own independent validation, etc. If I realize from a neighbor that somebody, I reach out to a neighbor, hey, have you seen this? Hello? Shit, there's nobody there. We've lost a node. I then look for who's the nearest node to the pieces of content that I need to back up. And we start recruiting a new validator to hold on to that content. And that's the way in which a DHT is self-healing. But the other piece here is, because this is the process, it's lightweight enough that you can have just the mobile device as a full node for an application. Even if that application is Facebook scale, even if you had 50 of those running on a device, we've already demonstrated that you could have 50 Facebook-size apps running on just a Raspberry Pi, right? And so and as a full participant. So that enables you to have the actual distributed architecture, right? You can have it runs on just the devices of the users themselves. You don't need somebody else who has, a bank of servers to do mining or whatever. The other piece that becomes interesting there is that the user, because they're holding on to their own content and because they've got their own copy of the code, if they start experiencing something where they're like, I don't like how this is working, they can change the code. They can decide to start playing by a different set of rules. And anybody else who wants to play by that different set of rules can come play with them. Now, that said, that does involve them forking off into their own reality. Right?
Yeah, I was going to say that means a fork, right? Yeah,
it's right. It's a fork. They're now playing by a different set of rules. They're not talking to those same people. Yeah. There, however, is a midway step, and that midway step is to do both. I'm running the old version of the app. I'm also now running a new version of the app, and I'm willing to bridge between these two, because anything I can read out of one, I can write into the other, and vice versa. Okay. Right? And I'm doing that not through an API. I'm doing that through my own agency, that I was able to read something in the one space. Yeah. And then I've got the speaking ability in the other space. I'm able to write it into the other space. So let's say it was that you had said something nice about me, right? You've said that I had a clean home or a clean car, right? And this is peer-to-peer Uber over here. And I've got a peer-to-peer Lyft, like an alternate ride-sharing app over here. You said I have a clean car. Well, I can write a couple of things into this other space. One, I can write into this other space that I am this, with using my private key here, that I am this other party in this other app.
Well,
so I can sort of bridge the identities. Two, I can pass along the content that they had said about me, this identity here, into that space, and I can sign that as well. And it's got their signature. When this, my key in this other app, it can then write that into that space and go, hey, here's the nice things that have said about me over there, right? What that does is it bridges two social spaces.
Yeah, now, and also connects it and also verifies different identities on different platforms, if it would be different platforms as well.
Now, there's a caveat here.
Okay.
The person who receives that message, they then have to have some mechanism of checking the signature. Now, they might be also running that other application, so they could check it directly. There might be an interface that community has made available for checking signatures. They might have a friend or a colleague or somebody else who's also running that application that they trust to check the signature. But there has to be, the way that reputation actually works in the real world is that you're bridging existing social relationships. I know about Harvard. I have respect for Harvard. I trust that when they put somebody through their process of creating an engineer, that it's a useful process. When somebody comes to me with a degree from Harvard, it's able to leverage that existing trust relationship to make it so that I don't have to spend a bunch of time with you before I'm willing to go, oh yeah, I'll waste half an hour on giving you a job interview, because I'm bridging the existing social relationship and the statement that
exactly.
My counterfactual there is, if I show up in the middle of the Amazon with some tribe who's like a hunter-gatherer tribe, and I'm trying to convince them to let me cook dinner for them, or that they should give me some food, I could show up with my credit score that was given to me by some credit agency in the United States, right? And say, hey, you guys should cook food for me. Check out my credit score. That's not going to work.
No. Oh,
they don't have relationships with that entity.
Exactly.
It doesn't mean anything in their world. It's not how reputation works, right?
No.
So our take on it is, you're able to bridge these social spaces, but this is how reputation actually works. A party decides that they're going to make themselves vulnerable by exposing information about some other portion of their lives, some other community that they're a part of, some way in which they show up in the world. And then they're able both to make visible the good stuff, but this party now knows where to go look to find out anything else that I've done, right? And so it gives me some discretion, but it also gives them some control. It requires me to make myself vulnerable in some way to be able to leverage the relationship, the reputation there. And so it's a distributed identity and reputation system as well that's not top down. It's being negotiated by the parties themselves. And I'm not going to share everything in my life into this context. I'm going to share relevant information that's useful for them that makes it easier for that party to make a decision about whether or not
what's relevant for their decision, what they actually need for it.
Exactly. So the long story short here is, what we think Holochain starts to enable is not just a distributed app to be run.
Yeah.
It's an ecosystem of distributed applications that's actually person-centric. It's centered on the user bridging between these spaces and deciding which applications they want to participate in, rather than it being centered on the application.
Yeah. This is why I really like this idea. It brings it just to, we are all people in the end of all of this. We are people behind computers doing things online. And it should be like that as well. We should still have that human interaction-ish online, like with each other.
And there's a security reason for that too. Mm-hmm. Security reason is that it's your people who will experience pain if something starts failing.
Yeah.
Or who will experience a positive experience if something seems to be working really well. As a result, if your people are the ones experiencing this stuff, it's your people who need to be able to take an action based on that experience. Yeah. They need to be able to go, ooh, this is great, I want to do more of it. Ooh, this is terrible, I want to never do that again.
Exactly.
And it actually enables your individuals, but also your ecosystem as a whole, to learn from the lived experiences that are happening.
And improve upon that, and actually, in the long run, make everything better for what we see as is a good alternative and a good choice.
That's right. And so we were designing so that the system in an ecosystem sort of way, as well as the individuals, were able to adapt and learn from their experience. Not in an AI can see the top of everything way. No. That's bullshit. That's not a system that will be functional and thriving on an ongoing basis. That actually creates a monoculture. Mm-hmm. And a monoculture optimizes for the existing context and gets sideswiped and goes extinct as soon as the world changes a little bit. That's not a functional system. You actually want a diverse ecosystem where there are failures, where people try stuff and it doesn't work out sometimes, and they learn from those failures. That's what we've been trying to build, is an ecosystem that is anti-fragile rather than than being an ecosystem where there aren't failures. Failures are an important part of learning.
Yeah, they happen, and people do fail, and the bugs and programs get developed and might be wrong. And people update it over time, and it's just part of life.
It's part of life. And these are digital systems that touch the real world, right? So even if the machine language, the math, et cetera, of your system is perfect, as soon as it touches the real world, people are going to come up with ways to fool the system or work around the system. Mm-hmm. And you need the internals of that system to be able to have the complexity and the dimensionality and the variety necessary to react to the complexity of the world around them. There's a principle around this called Ashby's law of requisite variety, which basically says that an organism or a system needs to have as much variety available to it internally, or at least representation available, the possibility of representing this variation internally, as there is external to the system. Otherwise, it is not able to maintain its balance. The external system will throw it off balance, and it won't have the responsive capacity to be able to sort of counter those experiences. So that's deeply geeky technical stuff, but for us, it puts us in a very different place from the blockchain folks.
Exactly, because blockchain is just one way. That is how it is.
And it'll be perfect. We'll make it so there's never a failure. You can trust the network.
Yeah.
But they're defining failure in this really funny, limited way, right? Like, oh, well, the record didn't change. Well, sure, but you have a record of a diamond, but now somebody in the real world cut that diamond in half, and there's 2 diamonds. Yes, the record didn't change, but the physical reality that it was supposed to be representing changed. So what do? You know? Yeah.
Let me just turn on the lamp in here because it got dark. I really
sure.
1 second.
Yeah. You
look like was sitting in a cave.
Yeah, you are a little bit east of me and north, so it gets dark early.
Exactly.
Yeah.
But I must say I really like the ecosystem out of this, and the more I hear you speak about it as well, it's really making me want to be a part of this and actually try and do something with it. Yeah.
Well, let's do something else right now, because you're here on the call and you're pretty deep and technical on this stuff. And since we got a recording here, I think just in this conversation, I've probably made a bunch of things visible that I haven't really done a good job in a succinct way of making visible before. But let's start pulling apart what the issues are, what the shortcomings are, what the limits are at present of this, if that's of interest to you.
The limits, yes. I can see some limits within this. If it is not enough people coming into this space and actually want to be a part of this, is that an issue?
Yep.
It would be, let's say there's only 500 people that wants to do this.
Yeah.
And the space doesn't grow more than that. That could be an issue.
Yep, that would be a problem.
Because then it doesn't get too much influence by new people that have their opinions and their ideas to be expressed.
Yeah. And so you would have those people being able to run the systems they want to run. Like they're still able to communicate in that way.
Yeah.
A holochain works with just 2 people. Well, you wouldn't really have a vibrant ecosystem where other people are trying a pattern, learning from it, failing, finding something better, and then you're able to learn from the positive discoveries, because it's just a little tiny system. Yep.
Yeah.
So there is something that we're doing to counter that, and it's Holo. So Holo is separate from Holochain. Holochain is you can think of it as a pattern. Basically, it's a way of building and running an application that we're trying to give away to the world for free. It's open source, but there's also no built-in business model for Holochain, right? We don't have cryptocurrency. We don't have mining at the Holochain layer. when people run a Holochain application, the incentive for doing the work of running that app is that you get to participate in that app. It's a commons-based architecture. And if you don't want to bear the burden, great, you don't have to run that app. Like no problem.
No, exactly.
Yeah. Our take on it is that actually mimics how the real world works, right? Like you find it useful to know how to speak English.
Yeah.
So you went through the effort of learning English, and you retain English, you maintain internally that capacity, that set of associations and skills, and that facilitates you being able to coordinate, communicate, collaborate with others who also are English speakers. Nobody pays you to speak English, right?
No.
You hold on to that. You maintain the burden of that in order to interact. And we think that that's how these apps will work as well. That said, you don't want to invest a bunch of time and effort and energy in building and running your own peer-to-peer Airbnb application if there's only the deeply technical, geeky people that are early adopters to Holochain who are going to be able to book a room, right?
Exactly.
So Holo is this service application that enables the members of your community to decide, yep, I will let some spare capacity on my laptop get used for serving out websites to visitors.
Yeah.
Matthew's grandfather could open a browser, type ourbnb.com, and Holo will route that query through the dynamic DNS, will route that to Marvin's machine or Nora's machine or Sammy's machine. And when it gets to Marvin's machine, he goes, oh, great, I've got a web page for you, right? And pings Matt's grandpa with a web page.
Yeah.
Matt's grandpa says, I'm looking for a room in Paris. You receive that request. You then speak into the peer-to-peer application for that app and say, hey, I'm looking for the photos and stuff from Paris. Pull that content back from the application, assemble it as a web page, and pass that back to the user. And you do this back and forth, translating between the peer-to-peer space of this application and that web browser. When your machine does that work, you do a bit of this, a handful of transactions. You're then going to bundle up a log and say, hey, this is the work that I've done for this application. You pass that to the developer. The developer pays you through an accounting transaction in our mutual credit crypto accounting system, which basically means everybody has account balances. Let's say you've got 500 credits in your account. The developer has 10,000 credits in their account. He's going to pay you 5 credits. So now he has 9,995 credits and you have 505. He signs that, you sign that. There's a pair of notaries who also check and sign these things. And then you share it. Each of those parties shares to the distributed hash table. That's an extra, there's a couple of sets of extra layers of protection that we're building in there. The notaries, we're probably making it so that you have to get to a certain level of penetration of validation in the neighborhood of each of those pieces before this thing becomes considered good to go, right?
Okay. Yeah.
What that means is each of the parties who are participating in that transaction, their chains, their local chains, are basically locked while this thing is propagating.
Okay. Yeah.
But nobody else is locked. Everybody else can transact in parallel. And so you can do millions or billions of simultaneous transactions while having some mechanisms for defending against particular attacks, some sort of corollary to a double spend attack in the blockchain world. Is it possible for somebody to cheat? Yes. But if you start passing around bad data, again, it's got your signature on it, and it's going to make it so that you lose access to the community.
Yeah, your reputation will go down over time.
That's right. And so there are other mechanisms that the community can make use of. Oh, are we losing each other? We good? Yeah.
No. I don't think so. No.
So there are other mechanisms that the community can make use of, like credit limits or you had to have this much money in an escrow account before you became a member of the community, or you've purchased insurance, or whatever, right? So there's other mechanisms that the community can make use of for making it so that your game mechanisms aren't just at one layer. You're able to create game mechanics at many layers so that you are able to interact with the risk to reward ratio calibrated in a context appropriate way, right? Like if I'm doing a multi-million-dollar transaction, I'm willing to wait a few hours for the validation stuff, and I'm willing to pay a bunch of dough and, $40 or something, no problem.
It's worth that money for that validation.
Yeah. Exactly. If I'm sending a tweet, I'm not willing to wait a few hours, and I'm not willing to pay $40. It's a different.
Exactly.
Yeah. Cool. So that's one sort of set of things. I want to make visible a couple of other drawbacks, because this is appropriate. This is a way of building and running peer-to-peer apps. It's not the only way. It's not the only tool that people will need to use.
No.
One of them at present is when you show up as a user in an application, you are a user and a host. And that means that certain applications are going to be great for just smartphones, right? And other applications you might not want to run as a full node on a smartphone. If we're doing peer-to-peer YouTube, and let's say we write it in a dumb way where the video file lands as a complete file on my phone instead of breaking it up into small chunks.
It's going to be bandwidth.
That would suck, right? To have sometimes your phone's having to upload a 5 gigabyte file. That's going to be a shitty experience for you. It's going to probably be a poor experience for people on the other end.
It's going to be not a good time for anybody involved.
That's right. And so if you have a device that has low capacity, it's got a slow processor, it's on an expensive bandwidth connection, you're not necessarily going to want to be serving out big files from that device. Holo probably becomes useful in this context. Holo enables you to have that device as just a user. Hey, I'm showing up as a user in this space, not as a contributor. I'm relying on others to do, but I may be able to contribute from my home laptop or a plug device at my home that's contributing to that community, and we can offset my contribution for my use in some way, which enables you to have some lopsided sharing. But it is a shortcoming, right? It's another shortcoming. We're doing immutable logs, right? And that's useful in some contexts. It's not necessarily useful for every context.
No.
If you're doing peer-to-peer Uber, we're going to have to make decisions about, do we want to log the location of every user as they're driving around or as they're walking around?
It becomes a little bit too much information to be stored and also unnecessary to propagate out. So it's just scaling it back and also building privacy from the beginning. Privacy as a default.
That's right. And so you start making decisions about, okay, what layer, how do we want to do that? Where do we want to place that? Is it just when I'm making a request that and am I actually sharing my specific information, or am I only sharing my city? And then for people who are also in that city, they can read then a region. And for people who are also in that region, what are the mechanisms there? Is it that we're not having that layer handled at a Holochain thing at all? We do have a trusted third party at that layer. And those are design choices, right? But that's a way in which, hey, this is not necessarily perfect for all use cases, or it's only part of a solution, What are some other things? It's not by default designed to be anonymous. We're designing for social coordination, and so you're signing to every action that you do in this thing. So it's pseudonymous at the minimum. And you could make use of it with other protocols that anonymize your device in some way, right? But Holochain by itself is not really optimizing for anonymity and avoiding being seen or observed. That's stuff that you would want to, if that's important, you have to handle that as well in a different way.
Yeah.
Can you repeat that? You cut out a little bit there.
It's completely understandable since it's not anonymous in that way, and since it's peer-to-peer, you never can be anonymous with it. So it's better to build it with this trust instead.
Yeah.
And as you said as well, developers need to find other ways then to make the communication. If you want to have obscure communication on the network, you need to build it in a different way to obscure it. Yeah.
So, yeah, that's a few of the things that kind of pop to mind right away around, hey, what are some things to be aware of? The other one actually is not so much a limitation as just a truth about the transition. Holo is there to make it so that, hey, even if we build this Holochain app, we can talk to the whole world, right? People won't even realize that they're using a Holochain app. They think it's a website. They don't know they're talking to a community on the back end. They think they're talking to a company or, whatever.
Yeah.
So that makes it so that the transition can happen much more fluidly. But on the developer side of things, when you're building a distributed application, it's different from building a centralized application.
Yeah.
It's even different from building a blockchain type app, which is a centralized app run on a distributed network, right? Or a decentralized network. And so there's some mental shifts that are required there.
Yeah.
That said, we are doing the best that we can to make it easier for people to build in these new ways. One, they can build apps in JavaScript, right?
Yeah.
Two, we're building some tools for making it easy for people to rapidly do application development. Those are things like you literally do step-by-step, fill in the blank these questions, and some of the pieces of code get written for you because you wouldn't necessarily know that you need to write all these different parts.
Yeah.
Just stepping in.
It makes it a little bit easier, more friendlier for developers to actually take a step in and adapt their code.
Exactly. Because they're not used to thinking about a system where there is no one single truth. It's always from the perspective of the different participants. So, so that's a few of those.
Yeah, this is because I have an upcoming meetings with some people in Germany that do IoT things, and especially what you just said is to make it developers, to make it easy for them to step into this. Because I'm going to speak to these, I'm going to talk to their bosses, essentially, not actual devs themselves. But I need to I'm going to push this to them to ask if there is possibility for them to even try and develop or add these types of functions into it and look into Holochain especially.
Yeah.
Because for security standpoint, to make IoT devices actually functional, this is a very good solution for it.
That's right. Yeah.
And also, it's the security lay on it, and only my family should be accessed to go into the door. It just verifies those private keys that they hold. Nobody else should go in.
Yeah.
It is a brilliant idea that I want to actually push to some companies that I actually know it works within space.
Marvin, if you need any help with that, ping me. That's my job, right? My job is to be able to sit down and walk people, especially the non-technical folks, through what is this and why would it work? Why is it helpful in IoT? And just like and why you can see why this is useful. And I only have a couple minutes before I'm supposed to jump on the next call. But it's important that the two devices or the card and the door or whatever, they be able to interact locally without having to reach out to a general network, without having to that be available right off the bat,
Yeah, exactly.
That's critical for IoT infrastructure.
Exactly. And as the more I hear you speak about it, and the more I've read about it, it's becoming more, for me at least, this is a very good platform for this. It's actually to be built upon.
Yeah,
which is why I also wanted to come in and help out as much as I can with this.
Should I put you in touch with some of the folks on the developer side of our ecosystem as well?
Sure. You can send me their information. I can take on some contact with them. I'm not myself a developer, just to say it. I write code and I do sysadmin stuff. That's my hobby. But
I will put you in touch with Philip Beadle and Eric Harris Brown. Though they will be able to help either you or guys on your team or these folks in Germany. They'll be able to answer the technical questions, or, hey, if you want to put your hands on a keyboard and do some pair programming, awesome, let's do it. And they're creating new material every week, making it easier for people. Yeah. They're doing pair programming sessions and recording them and then making those available in our online community.
Oh, great.
Which is at chat.holochain.org. Adding that right now to the chat. If you haven't joined, that is great. We have an incredible community that's starting to mature, with lots of people willing to help one another out as they're wrapping their heads around what this stuff is and how to build with it.
Yeah, I think I'm signed up. I signed up a couple of weeks ago. I just haven't got the time yet to dive into it.
So here's what I'll do. Instead of pinging you right away with Philip and Eric's contact info, what I'll do is, when you have either a guy on your team or somebody from another company who wants to chat, I'm down to chat with them. But if they want the technical help, I'll connect them to these folks.
Oh, perfect.
Awesome.
I will have them talk with them in 2 weeks. So it's going to take some time before I meet them. But I will see what they say about it, and hopefully they're interested in it, because I think they are interested to secure their IoT devices. Also makes that a selling point for them. Yep. So,
well, and the other piece here is that this really lends itself to what Cisco calls fog computing architectures, or edge computing. Your device is super lightweight, but it's got some processing happening at a nearby cell phone or whatever, and you're able to do the processing and the storage at whatever layer in the network is appropriate for your particular architectural or your particular context. Yeah. Sweet. Marvin, so good.
Thank you very much for taking your time, Matthew, to speak with me.
What do you think? Should I make this available to other folks, this recording? Is that okay?
You do as you want. I'm fine with it.
Okay. I think there was stuff here that I haven't been able to make visible to others, just because of what your context and background is. This is definitely on the more technical end than a lot of the stuff that I'm speaking about. So I think I'll share it with my team, and they'll decide whether to put it up. But
I'm totally fine with it. You guys decide if you want to do it or not.
Is there a company that would it be useful to you in any way if this becomes visible for people to know where you come from, what your organization is? Your name is Marvin Lundquist, yeah?
Yeah, and my companies, we can remain private.
Fair enough.
Like that. Yeah.
We don't need to do that.
I'm fine going out as myself as a private person, but not on the company side like that. So.
Perfect. That's why people turn to you, because you're good at that.
Yeah.
Marvin, thank you so much, sir.
Yeah. Thank you very much. Have a good day.
You too. Bye.
Bye-bye.